So in 32, you have two similar triangles. The yellow and the blue. Therefore, you can set up a proportion to solve for one of the sides. What we did was 60, which is the yellow base, is to x, which is the yellow height, as 80, which is the blue base, you have to add the 20 and the 60, is to the blue height. We reduced this fraction, 80 44ths, to 20 11ths. We cross-multiplied and we solved. So that's just a recap of that one. And then for 33, what we did was we set up a proportion. These two triangles are similar because these two angles are congruent. This angle here is shared, so it's the same in both. And there's only one other angle, so whatever it is here, it must also be here since this is a straight line. What we did was we did yellow base is to blue base, so x minus 2 is to 30, as yellow right side is to blue right side. So again, you had to add these two, so just be aware of that. We reduced the fraction, got 1/3, cross-multiplied, solved for x, and then we plugged x in to the diagram, so this becomes 12 minus 2, or 10. Then I put 12 minus y here and 12 plus 2y here. And then we set up another proportion. We did yellow right side is to blue right side, so 8 is to 24, as yellow left side, 12 minus y, is to blue left side, and you have to add these two. So you would get 12 plus 2y plus 12 minus y. And when you combine those two, you get 24, and then 2y minus y is positive y. So 24 plus y is that length there. So that's how we're getting 24 plus y here. And then let's finish this up. I'll call in a random helper to guide me through the solution for getting y. Okay. Max, help us finish up, please. And for clarity's purpose, I'll rewrite where we're at. 8 24ths equals 12 minus y over 24 plus y. So where can we go from here? Yeah, let's make the math easier by reducing this fraction. 1/3. Now cross multiply. Good. Keep going. Mm-hmm. And you get 4y equals 12. Good. Y equals 3. Nice. Well done. Okay, any questions on 33? There's a problem, at least one like that in the textbook if you need more practice there. Okay. Now the last two. So let's put our similar triangle knowledge to a more like practical purpose. You can use it to solve for heights of objects. If you know the height of one object and how long its shadow is, and also the shadow length of another object. Okay? And a random helper is Shirley. How could you approach this one, number 34?
I set up a proportion.
Okay.
Actually, I drew out a visual representation.
Yeah, I love it. That's a great way to understand a problem better.
So I believe the tree is a lot bigger than the centimeter tall statue, so I made 2 triangles.
Okay, so let me just label this.
The bigger triangle with a height of x, and the base. Well,
Oh.
yeah, the base of 18 meters.
Yeah, thank you for saying that. The shadow is
Yeah,
18.
and then for the statue, the height is 64 centimeters.
Mm-hmm.
Bottom one is in between them.
This is 18 meters.
That's in between them.
It doesn't matter. Yeah.
With a shadow of 65 centimeters.
Mm-hmm.
So I set the proportion to be 18 over 65
18 over 65. Mm-hmm.
to x over 64.
X over 64.
And then I cross multiply
Okay.
by 1,152
Mm-hmm.
over 65. No,
Uh,
sorry, equals 65x.
Okay, then you divide it by 65.
Yeah, and then I divided by 65 and I got 17.72 after rounding. Oh, 6, yeah.
Yeah.
So then rounding to 17.72.
Yep. It's going to be okay. Any questions on 34? So notice that the units are mixed here. You could make them the same, but it's not necessary for this particular problem. Because what happens that it ends up canceling. For example, if you converted this into, like if you converted these into meters, so 65 centimeters is how many meters? Anyone? 0.65. And then same thing over here. What this is the equivalent of doing is multiplying these denominators by 1/100th. And anytime you do something to one side of an equation, you do it to the other side, but you haven't changed anything about the equation, really. It's still balanced, so that's why it doesn't really matter. Okay. Any questions on 34? $35. Another random helper. Jake. Let me draw it out first. Doesn't have to be to scale. We have a triangle drawn on a map. Sides are 9, 10, and 15. It says the shortest of the corresponding real-life distances is 134. Oh, yeah, that's fine. We can do that. Good? Mm-hmm. Go ahead.
9 over 34.
9 over 134, I believe.
Equals 15 over x.
Mm-hmm. And tell me why you chose 15.
Because it's the longest side of the triangle.
Very good. Yeah, we're given the longest distance. Okay, and then how would you solve that?
9 times x equals x. And then 15 times 134 is...
This is why I asked that you bring a calculator. So it's 2010.
Oh, wait.
Next time, Jake. So when you divide by 9, you get 223.3 repeating. So choice A. Okay? And later on, we will do a lab in which we get outside and actually calculate the heights of things, and this is one of the techniques that we'll use. So one of the cool things about Trig is that there are a lot of real-world applications and applications that you, as high school students, can do. Okay. Any questions on anything in this packet? It's pretty much section 1, 2. Angle relationships, like vertical angles, and angle relationships in triangles, triangle classifications, similar triangles, applications of similar triangles, or working with similar triangles. Okay, again, any questions? All right.